Hello everyone, my name is Michelle Gohuki and my matrix number is AD170246, and I will gonna present about the brief result from calculation method. By using the equation of motion in the matrix form, substitute all the parameters given for the m1, m2, k1, k2, then by using the equation of motion standard matrix iteration for finding the highest and the lowest natural frequency. So now for the neoprene, we have the care of 350 kilonewton per meter. And from there, we're gonna have matrix 6 iteration method to find the lowest natural frequency for neoprene. And we got our lowest natural frequency for neoprene is 43.5277 radian per second. While for the highest natural frequency for neoprene, we have 6 matrix iteration method too, and we have the highest natural frequency of 105.7261 radian per second. Here comes for the motion, and we with the k equal to 600 kilonewton per meter and use the same equation of motion as before. This is the matrix iteration method that we have calculated for the subroutine, and this is for us to find the lowest natural frequency of it. And we have made 8 matrix iteration method for subroutine, and we got the lowest natural frequency of 56.9932 radian per second. While for the highest natural frequency of subroutine, we got 138.4280 radian per second.
My name is Stefani. I'm going to present about the review on validation method that we chosen. The validation method we choose is using the MATLAB. MATLAB is a macro tool that use a formal method-based static analysis to find the errors and also help us to achieve higher quality of design. With the MATLAB, we used to validate the calculation done by using the matrix iteration method to help us find the better material of isolated pad. This helps to trace the requirements to the real-life architecture, the design, and also the test. This also helps us to prove that the material meets the requirement that requested. So in first step, we need to insert the K, that is the matrix of the stiffness, and then we insert the matrix of the M, that is the masses, then we times the inverse K with the M. So next step, we times the eigen bracket A, that is the eigenvalues of the square matrix. So the natural frequency we get by equal 1 over square root the eigen first row values, then the omega 2 natural frequency we get by 1 over square root eigen value of the second row. So for the next step, we need to find the mode shape. In first, we times the bracket VD is equal to the eigen bracket A. So the D is the square matrix of the eigenvalues. Then we can find the mode shape by times the eigen1 equal to V bracket 1 over the V bracket 1 1. So the V2 mode shape we can get by V bracket 2 over the V1 2 to get the second mode shape.
I'm Ko Ching Yong. I'm going to show the validation process using MATLAB for neoprene. First, we insert the value K, and then it shows the value of matrix of K, and then we insert value of M. For our group, our M1 is equals to 98 and our M2 is 59. And then we input A equals to inverse K multiplied by matrix M. And then EIG is engine value, and then the engine value will give lambda. And next we proceed to omega 1. Omega 1 equals to 1 over square root EIG 1 to 1, and then omega 1 is actually the highest natural frequency, while omega 2 is 1 over square root EIG 2 to 1, and this is the value of the lowest natural frequency. Next, we insert BD equals to engine EIG bracket A, and this is the mode shape matrix. And from this, we insert input V1 equals to V1 over V1 to 1, and this is the second mode shape. And V2 equals to V bracket 2 over V1 to 2, and this one will be the second mode shape. And that's all for neoprene process.
I'm Hosuki, and now I'm going to talk about the validation using MATLAB for Soboton. Now, this is the value for care matrix, and this is for the M matrix is this one. And we calculate the A using the inverse K times M. So this is the answer. And we proceed to the Eugen value by using this formula for the Eugen A formula. So this comes out for the answer. And we calculate the natural frequency, the highest one, using the formula this. And this value is our highest natural frequency. While for the second natural frequency, we're using this formula. So this one is our lowest natural frequency. Now we're using the continuous formula, this one, to find out for the mode shape formula. So we continue with this formula to cut out for our second mode shape. This one is our second mode shape. And for the first mode shape, we're using this formula. So this one is our first mode shape for Soboton. That's all.
I am Mong Cha Hui, matrix number AD170224, and I will present on the discussion on calculation and validation result. We use matrix iteration method to calculate for the highest and lowest natural frequency for both neoprene and Soboton. So in the slide, table 5 shows the result obtained by using matrix iteration method, and the mode shape are on the right side of the slide. The table 6 shows the result obtained by using validation method, which we use MATLAB. So the mode shape are in the right side of the slides also. So let's move on. In table 7, the percentage error between matrix iteration method and validation method. From table 7, it is shown that the differences between the percentage error between the matrix iteration method and the validation through MATLAB are extremely small and can be said as approximately equal to 0 for both material. So it is proven that the lowest and highest natural frequency calculated by matrix iteration method are correct.
As for the conclusion, we're able to justify that the material of Soboton is the best material can be chosen to be used as the coupling isolated plate. Theoretically, Soboton is the best material compared to the neoprene material. The selection of the material that has been made after comparing the natural frequency obtained with the forcing frequency, which is at the optimum speed that was given for the isolated plate, which is 107 radian per second. The closer of the natural frequency to the forcing frequency gives the higher tendency of causing resonance to the system. In the analysis we have made, the highest natural frequency from the Soboton gives the most difference with the forcing frequency. It proves that Soboton is the most suitable material for the isolated plane. That's all from our group. Thank you.